Welcome to today's webinar, the NFPA 70E, How the 2012 Updates Affect You, hosted by NTT Workforce Development Institute. The large number of registrants, 1,100 plus, shows the interest in keeping up to date with the NFPA 70E 2012 standard. We will present an overview of the important changes in this revised edition. During the presentation, all lines will be in a listen-only mode. If you have a question, please select our presenter's name, Larry Lenhardt, in the To field, type your questions in the Say field, and then press Enter. We will answer as many questions as possible at the end of the presentation. However, if the presentation concludes and your question was not addressed, we will respond via email using the contact information you provided when you registered. You can also contact Debbie Jones, whose information is on the screen now and will be displayed again at the end of the presentation. If at any time you experience technical difficulties, please press *0 and an operator will intercept your line privately to assist you. Our presenter today is Mr. Larry Lenhardt. Larry launched his electrical career in 1962 at the Army Security Agency and then spent over 30 years working at a major Midwest utility company. He began his safety career at Alliant Energy developing and implementing their safety practices and procedures. He was actively involved with the IBEW as Safety Committee Chairman and has been appointed to several electrical committees dealing with NEC, NESC, and other related safety issues. He was appointed by the Governor of Wisconsin to the Committee on Free Enterprise. He is also the 2001 recipient of the Distinguished Service to Safety Award from the National Safety Council. Larry is a published author and is certified by the judicial system as an electrical expert. Larry joined NTT in 2001 as an instructor of electrical curriculum and development. He's conducted extensive national and international training for NTT's clients. Today, his primary responsibilities are to help consolidate client activities into a singular systematic electrical safety program that's customized for each client's unique needs. Now, Larry, I'd like to turn it over to you.
Thank you, Samantha. I want to welcome everybody today to a cursory review or a brief overview of the changes taking place in the 7E of 2012. Just for everybody's information, these changes did take place effective August 31st, and it's intended to supersede all previous editions. And, of course, many of you know the latest edition was in 2009. One of the questions maybe we should ask is, why do we want to implement and why is 7E so important? Well, give you an example. As I was preparing this presentation just a few months ago, I was doing this. The day I was doing it, I had an email show up to me from Cal OSHA, and this is an example of what's going on in the industry today. This is dated November 16th of 2011. This is in Hartford, Connecticut. It says the U.S. Department of Labor's Occupational Safety and Health Administration has cited Lewis & Company for 29 alleged violations of workplace safety standards. The manufacturer faces a total of $177,000 in proposed fines following safety and health inspections conducted by the Hartford office. The cited hazards include untrained employees working on live electrical equipment without adequate personal protective equipment, on-grounded lamps and electrical receptacles, damage and misuse electrical equipment and cords, not using hazardous energy control procedures during maintenance of machinery. And this is a consistent theme that we have been seeing for quite a few years. As an example, here's some more excerpts out of additional citations that I've looked at recently. The alleged willful violation stems from the company's failure to ensure the use of appropriate electrical protective equipment when employees were working on or near energized electrical parts. And you notice when you look at this willful is probably the worst thing we can be charged with. It means that the employer showed disregard or did not follow through on any rules and regulations. Next one, companies failed to ensure the use of appropriate electrical protective equipment when employees were working on or near energized electrical parts. Not training employees on safe-related work practices. And these are consistent themes that we are seeing in citations written by OSHA against employers. And why do we want to talk about what OSHA is doing? Because OSHA sets the law. OSHA sets something what we call performance-based language. And what we're going to be dealing with today is a set of regulations that dictates what the employer has to do and, of course, how the 7E plays into it. So in the general industry standards, there's a part known as Subpart S that is from OSHA Regulation 1910-301 through 399. And those regulations were published in 1990. And it was published in 1990. The whole concept of the injuries we looked at were simply dealing with shock. Specifically in Section 331 to 335, dealt with electrical safety work practices. And as you read the language in there, and many of you have, and many of you have implemented rules and practices over the years, it's called performance-based language. It tells the employer what they must or what they shall do. The problem is it doesn't tell us how to do it. Well, in the early 70s, OSHA went to the NFPA organization and asked them to write a set of consensus standards to help develop rules and practices at that time dealing with shock. Well, we've had quite a few revisions over the years, and in the year 2000, the industry recognized ARC as a hazard also. And it's a consensus standard. And a consensus standard basically is a best practice or how to accomplish standard. And as I go through this presentation, I'll read a thing or two to you that says if we follow the 7E, you'll be able to demonstrate to OSHA you're using industry-recognized practices. So what's changed in the 2012 that's different from 2009? Well, if any of you have a copy of the 7E around, on a couple first pages, it talks about some major revisions that have been made to Article 90 in Chapter 1, which basically deals with the work practices that most of you are acquainted with. First of all, it's been changed to be more in format with how the National Electrical Code has been put together. They removed many definitions that are no longer in use. They've added a significant change for many of you out there. FR, or flame-resistant clothing, has been used in the past. Well, they've changed that to arc-rated clothing. Why? Because many companies are using FR clothing, but it's not what it's designed to be used for. Article 105 is new. One of the other significant changes we'll get into is a 3-year interval for retraining and auditing of your programs. Another one is the workplace requirements for GFCIs. It's been in the NEC. It's being reinforced again in the NFPA 70E. Another area that's been moved around is working while exposed to electrical hazards. There's a move to Section 130.3. New safety-related work practices for underground. There's another section that says individual qualified employee control procedures have been deleted from Article 120 and moved to another section of the standard. Clarification that requirements of Article 130 apply whether incident energy analysis or a hazard risk table is used to determine the use and level of PPE has been provided. New requirements and information have been added covering the use of PPE to protect against Arcflash associated with an enclosed electrical equipment. I know from my own experience, and I've recognized some of the people who have logged into this presentation, the question has many times come up, does this apply to people that do switching? Does this apply to my operators? And unfortunately, I've told the people in the past, yes. It's been further clarified in the standard. The content of the Energized electrical work permit has been revised, and its use has been clarified. There's been a new approach, boundary, and hazard risk category tables associated with DC. DC has been an ongoing question over the years, and Appendix D has been added for Arcflash calculations dealing with that. A requirement for hearing protection when working within the Arcflash boundary has been added, and that's significant. Arcflash protection for hands have been revised to specify heavy-duty leather gloves. Another one down here, number 17. Over the years, we have seen changes in clothing. There was in the 2009 standard a Category 2 put in that added a balaclava to the head. That has simply been deleted, and it now becomes just simply Category 2, which mandates a balaclava. Some of the tables have been revised, and we'll get into a few of those. And there's new information requirements to the equipment labeling provisions have been clarified and added. And there's an exception for existing installations that has also been added. So it's basically said if you have done a calculation in the past, we don't have to go out and change those labels. So what are those hazards of electricity we're talking about? Well, all of us have known about shock. I would venture to say every one of you that's been listening to this has been shocked either with static or been on a job where you've had shock from making contact with energized parts. In 2000, arcs were recognized in the industry we're in as a hazard. And associated with an arc, about 5% of the time, there's some type of blast or explosion. But here's where the big changes took place. Which one creates the most deaths? Well, we think pretty much all know that the number one thing that causes death out there today is shock. And that was taken care of and accounts for about 90% of the fatalities associated with electrical work. But if we ask which one creates the most injuries out there, that is totally different. Arc fires account for 75 to 80% of the injuries for people who are working with or associated with doing electrical work. According to the National Safety Council, to the NFPA organization, Bureau of Labor Statistics, electrocution today is the fourth leading cause of industrial fatalities. We know that there are basically 500 deaths per year on systems of 600 volts and less, and all we're talking about here is basically general industry. If you throw in construction, you throw in other things, that number is going to go over 1,000. We know from the data provided by the NFPA organization in the latest edition of 2012, there's approximately 9,600 incidents per year where an employee has been hurt in an arc that requires some type of medical treatment. And out of that, that means there's going to be approximately 2,000 people are put into an Arcflash burn center this year and next year. And what does that really mean? That means someplace in this country today, approximately 5 to 6 people are going to end up being burned today, and they're going to end up in a burn center. I don't believe any of us want to have that happen at our place of employment. Electrical work, then, is the 10th most dangerous occupation in terms of fatalities. So to go back to OSHA, OSHA's got a concept out there called hierarchy of control. And it puts a burden on the employer. The first thing to do is basically remove that hazard. Buy equipment that doesn't have a hazard. Well, that's possible in some areas, but when we got electricity, we're going to have a hazard. So it says engineer it out. We got engineering controls. We put it in enclosures. We guard it. We do so forth. We use overcurrent protective devices. But when that doesn't work, then the standard says we got to go out there and find some way to protect our employees with the appropriate PPE, tools, work practices, and so forth. And once all that's been in place, the last thing we got to do is have an employee assume that risk using the appropriate PPE and find a way that will meet OSHA's requirements for you to demonstrate good faith in protecting that employee. So we look at the OSHA regulation that deals with it. As I said, subpart S, here's the scope of that regulation. And it's interesting who it covers. It says covers work both by qualified and unqualified persons. It says the provisions of 331 through 335 cover electrical safety work practices for both qualified persons, those who have training in avoiding the electrical hazards of working on or near exposed energized parts, and unqualified persons, those with little or no such training, working on, near, or with the following installations. And then it goes on to give us the types of things that are out there. So maybe the question we should resolve right away is, what is a qualified person by OSHA? Well, effective August 13th, when they revised part of the standard, they defined a qualified person as one who has received training in and has demonstrated skills and knowledge in the construction and operation of the electrical equipment and installations of hazards involved. I know in my own case, only thing I had to do in the past to become a qualified person was to basically demonstrate my knowledge. It could be done with a test and so forth. But when you demonstrate skills, it means you've got to be observed, it's got to be documented, and it's got to be on file. Now, if we jump to the end of this particular standard, the last thing we were supposed to do then is put on the appropriate PPE and assume the risk. Well, here's the language that comes from OSHA. And again, it's performance-based language. Simply says employees working in areas where there are potential electrical hazards shall be provided with and shall use electrical protective equipment that is appropriate for the specific parts of the body to be protected for the work performed. Well, I don't see anything in there that tells me about what I'm going to be putting on it. It says I got to protect them. The OSHA regulation doesn't really lay out what it's going to be. And there are several other things in here. Another one in here. Employees should wear non-conductive head protection where there is danger of head injury from electric shock or burns due to contact with exposed energized parts. Employees should wear protective equipment for the eyes or face where there is danger of injury to the eyes or face from electric arcs or flashes. or from flying objects resulting from the electrical explosion. As you can see in this picture in here, we've got some clothing, we got some rubber gloves and so forth. Well, where did those come from? That comes out of the NFPA 70E. As we continue to go on, when working near exposed energized conductors or circuit parts, each employee shall use insulated tools or handling equipment if the tools or handling equipment might make contact with such conductors or parts. If the insulating capability of insulated tools or handling equipment is subject to damage, insulating material shall be protected. Again, some type of a tool. And again, the industry has set forth standards for those types of tools. And I don't mean putting tape on a screwdriver or dipping them in our can years back that used to have the plastic dip in them. And finally, protective shields, protective barriers, or insulating material shall be used to protect each employee from shock, burns, or other electrical-related injuries while that employee is working near exposed energized parts which might be accidentally contacted. And, of course, we're dealing with an exposed part or where dangerous electric heating or arcing might occur. And here's where we get into it. You see a picture up here. Is there a potential hazard there? Absolutely. Simply switching there could create a hazard. Something goes wrong in there, we've got an enclosure door, and it's possible for that door to come out. So why do we look at the 70E? Well, right after the 2000 edition of the 70E was published, an electrical contractor wrote a letter to OSHA asking him, how does the 70E fit into my program and what do I have to do? Do I have to follow 70E? And this is the response that was written back, an excerpt out of that letter of interpretation. So OSHA does not per se enforce the NFPA standard. OSHA considers the NFPA standard a recognized industry practice. And many of you know there's a general duty clause out there that says OSHA in cases can enforce and use the industry practice as a means to demonstrate you're doing good faith for your employees. The employer is required to conduct an assessment in accordance with 1910-132D1, which is the PPE standard. If an Arcflash hazard is present or likely to be present, then the employer must select and require employees to use the protective apparel. So this is the important part. Employers who conduct a hazard risk assessment and select and require their employees to use protective clothing and other PPE appropriate for the task, as stated in the NFPA 70E standard, are deemed in compliance with the hazard assessment and equipment selection OSHA standard. So if we look at the scope now of the 70E, what does it cover? And it relates basically back to the OSHA reg. Why? Because when the OSHA regulation was published in 1990, they actually cut and pasted out of this standard that was in place at the time. Covered. This standard addresses the electrical safety-related work practices for employees working that are necessary for the practical safeguarding of employees relative to the hazards associated with electrical energy during activities such as installation, a new word inserted, inspection, operation and maintenance and demolition of electric conductors, electrical equipment, and so forth. This standard also includes safe work practices for employees performing other work-related activities that can expose them to electrical hazards, as well as safe work practices for the following. If you see bold language in this, this is new language that was added in 2012. The installation of conductors and equipment that connect to the supply of electricity. The installation used by electric utility, such as office buildings, warehouses, garages, machine shops, and recreational buildings that are not an integral part of the generating plant, substation, or control center. But I always get asked, what other types, what does it mean, doing work? Well, right out of the NFPA 70E, these are the types of tasks that are covered then by the standard. It's not inclusive, but it says the operation of a circuit breaker or fuse switch, either with the door open or door closed. It's very clear today. Resetting of circuit breakers, replacing fuses, voltage testing, troubleshooting, installing, removing circuit breaker or fuse switch, opening a closed hinge door, removal of replaced folded covers. Why? During that process, things can go wrong. Insertion, removal, racking of breakers. Perform infrared thermography. Many people call it infrared scanning. Application of protective grounding, putting them on, taking them off. Simply the inspection of the electrical equipment. How many places do I go into that they ask me, there's an engineer, an electrical engineer, opening up a cabinet covered by the standard? The answer is yes. They're inspecting it, they're doing it. Things can go wrong. Basically, any interaction with electrical equipment at 50 volts or more, or where an electrical hazard can exist. That's what's covered by the 70E. So let me show you what I'm talking about. I've got a couple of graphic pictures in here, some people and some damaged equipment. Right here's an electrical room. Far end of the cabinet, you can see the wall, some black marking on the wall. Two contract employees were in this facility, opening it up to do some work and get some information off this circuit breaker. During that process, it blew up on them. This is one of those people. Yes, he's healed up from it today, and actually, folks, this is a minor burn. They tell us today the average burn from an electric arc is about 75% of the body, and that first one there is probably a 5 or 6% body burn. Here's another individual I've met over the years, right arm, second, third, and fourth, and onset of some fourth-degree burns. This is another individual that lost all the flesh off the back of his hands from being exposed to an arc, not wearing the proper hand protection. This is electrical equipment that's gone into an arc. You can see there used to be copper bus bar there. And most of these arcs only last 1/10 of a second. Another one here. Some more electrical equipment. And it can be catastrophic. It can open up ceilings. It can blow parts of buildings away and cause extensive damage. And in this particular photograph here, I noticed somebody from this particular company logged on this morning. This one cost a man his life. Now, as I said, one of the things that changed out there is some definitions, and this is a significant change. Arc rating. This is dealing with clothing. The value attributed to materials that describe their performance to exposure to electrical arc discharge. The arc rating is expressed in calorie centimeters squared and is derived from the determined value of the arc thermal protection value. Folks, simply this. Today, for clothing to be used for this protection, it has to have a label in it that says ATPV, arc thermal protection value. Just saying FR is not good enough. If it says FR, there still has to be a label in it to identify it that it meets that requirement. And that arc rating has to be equal to or greater than the hazard they're facing. Another change that took place is they simply moved the requirements for contractors and multi-employer relationships in the standard. But here's some documentation that was put in there. There shall be a documented meeting between the host employer and the contractor employer. Ask yourself what we've done in the past. I know I came out of an industry, you hired a contractor, you just let them alone. We are now held accountable to make sure that they know our rules and practices. Emergency procedures have been updated for people who have to respond to an emergency situation, such as employees responsible for taking action in case of an emergency shall be trained in methods of release of victims from contact with exposed energized electrical conductors and circuit parts. Unfortunately, many of us have rescue teams and so forth that have no training in how to remove somebody or protect themselves in electrical condition. Are they wearing the right kind of clothing? Do they understand the potential for shock and so forth? Training of employees in approved methods of resuscitation, including CPR and AED use, shall be certified by the employer annually. And that's a key word. Many providers out there give you a 2-year certification, but this standard mandates it be annually. And I asked recently when I was at the NFPA conference, why annually? And the consensus was we lose too much of our knowledge if we don't use it routinely. So what's the definition of a qualified person under 70E? A qualified person shall be trained and knowledgeable of the construction and operation of equipment or specific work method and be trained to recognize and avoid the electrical hazards that might be present with respect to that equipment or work method. Although this one doesn't say demonstrated proficiency such as the OSHA regulation does, it is covered in the employee requirement for documentation, such as an employee who's undergoing on-the-job training for the purpose of obtaining the skills and knowledge necessary to be considered a qualified person and who, in the course of such training, has demonstrated an ability to perform specific duties safely at his/her level of training and who is under the direct supervision of a qualified person shall be considered to be a qualified person for the performance of those specific duties. So again, more requirements. So what do we got to do then for a qualified person under the standard? One who has skills and knowledge related to the construction and operation of that equipment. Pretty straightforward. So the employer shall then determine on a routine basis through regular supervision, conduct at least an annual basis that each employee is complying with the safety-related work practices by the standard. Ask yourself, what does it mean, regular supervision? Well, this is the way it was explained to me by several OSHA compliance officers. a company or organizational representative who gets to the job site often enough to make sure the work is being done right. How many of you folks listening to this presentation today go out and see what your people are doing? Are you qualified? Do you have the knowledge? Are you properly dressed? Do you know what's going on around you? The standard in the OSHA regulation says somebody who oversees this work also has to be trained as a qualified person. Again, 7E, unqualified persons shall be trained in and be familiar with any electrical safety-related work practices necessary for their safety. I don't know how many of you have, but if you would want to do a little research, I suggest some of you folks go back and do a search on something called OSHA's Dress Rehearsal, an article written by Mr. Buss from the NFPA 70E, or you can contact us at NTT, and I'll provide that letter to you, giving you an idea. What are they looking for? Retraining is a new part. Retraining shall be performed at intervals not to exceed 3 years. I think that's going to have a major impact on many of you sitting out there. Training documentation. The training shall document that each employee has received the training required by 110.2. Section D, this documentation shall be made when the employee demonstrates proficiency in the work practices involved and should be maintained for the duration of the employee's employment. Here's some new language. Please pay attention to. The documentation shall contain the content of the training, each employee's name and dates of training. Now, that's new language to the 70E, but it is not new language from OSHA. Mr. Mastrulo, a compliance officer out of the Northeast, at the training session that I attended earlier this year, said that's been in the OSHA regulation. When they're looking for content, who, what was involved, and it needs to be documented and kept on file. So, what does an ARC look like? Well, let me give you an idea from a security video that was provided to me a year ago out of Florida. This is a minor incident. As you watch it here, this is from a security camera, so it may look a little choppy to you, but this is an ARC that took place. This is a person wearing street clothing. Their clothing is burning. And that's how fast it can happen. Nothing major, but it can happen very quickly. So as we go on here then, what do we have to do? What kind of a program we got to have in place? And again, I don't have time to cover everything that's in here, but it says an electrical safety program shall include a hazard identification and a risk assessment procedure to be used before work is started within the limited approach boundary or within the Arcflash boundary of energized electrical conductors and circuit parts operating at 50 volts or more where electrical hazard exists. This language is going to have a major impact on many of you sitting here. Prior to that, the limited approach boundary was based upon an exposed part and piece. And for systems of 750 volts and below, that was basically 3 foot 6 inches. But when they added this language, or within the Arcflash boundary, I've been at some of your facilities. I've seen Arcflash boundaries in some cases that are 20, 30, 40 feet away. That is, again, going to change the way you have to do business. The procedure shall identify the process to be used by the employees before the work is started to identify hazards and assess risk, including potential risk mitigation strategies. What are we talking about there? Can we shut it off from someplace else? Can we do it at another time? Do we have to do it today? So forth. Whatever you can do to mitigate that risk. Earlier on, as I said, one of the changes that was in there is an auditing requirement. It says electrical safety program. The electrical safety program shall be audited to verify the principles and procedures of the electrical safety program are in compliance with this standard. The frequency of the audit shall not exceed 3 years. So what are we going to be doing out there? What kind of program are you going to be putting together to have a qualified person audit the principles and procedures you have in place? Field work, another new section. Field work should be audited to verify the requirements contained in the procedures of electrical safety programs are being followed. Why is that important? Because many of us send people out in the field, not at our location, to be a contractor. We need to go out and see what they're doing. When the auditing determines that the principles and procedures of the electrical safety program are not being followed, the appropriate revisions to the training program and revisions to the procedures shall be made. And again, documentation. The audit shall be documented. We all know what they say. If it isn't documented, it never took place. Who did the audit? Where were you at? The equipment involved, the people involved. Document, keep on file. Use of equipment, testing and instruments. Testing. Only qualified persons shall perform tasks such as testing, troubleshooting, voltage measuring within the limited approach boundary of energized electrical conductors or circuit parts operating at 50 volts or more where electrical hazard exists. Again, right now I go into facilities and so I ask people, what are you folks doing? I got an operator, I got some, I do a voltage check, I do this. The standard says that individual has to be a qualified person for the task they're performing with the appropriate PPE. Conductive work locations, new language again, important note. The hazard risk evaluation procedure could also include identifying when the use of portable tools and equipment powered by sources other than 120 volts AC, such as batteries, airs, hydraulics, etc., should be used to minimize potential for injury from electric hazard for tasks performed in a conductive or work location. So what is a conductive or wet location? Well, by definition, that's any electrical equipment mounted inside or outside subject to water or moisture. So how do we protect people out there then? This is a part that's been added into the standard, GFCIs. Employees shall be provided with ground fault circuit interrupter, a GFCI, where required by applicable state, federal, or local codes and standards. Listed cord sets of devices incorporating listed GFCI protection for personal identified for portable use shall be permitted. So again, are we using them? And then basically what we're talking about is that GFCI needs to be on the plug-ins. I just want to say plug-in, plugging my tool into that or my extension cord into that to protect both the cord, the tool, and the individual using it. Devices. This is the language that's more specific. GFCI protective devices shall be tested for the manufacturer's instructors, and when it's outdoors, it says the GFCI protection shall be provided when an employee is outdoors and operating or using a cord and plug connected equipment supplied by 125 volts, 15, 20, or 30 amp receptacles. Where employees working outdoors operate or use equipment supplied by other than 125 volts, an assured equipment grounding program shall be implemented. If you're not familiar with that, it means all your cords, all your tools have to be checked for polarity, continuity, tagged, and a record kept before they're ever used and pulled back out of service every 90 days and redone again and over and over. New section 110.5. Before, this has never been in here before. Been asked many times in the past. What about underground? Well, most of the states I've ever been into, if you're out there digging in the ground, digger's hotline, 3 days notice, and so forth. But what about on your own properties? Before excavation starts, and where there exists reasonable possibility of contacting electrical lines or equipment, the employer shall take the necessary steps to contact the appropriate owners or authorities to identify and mark the location of the electrical lines or equipment. When it has been determined that a reasonable possibility for contacting electrical lines and equipment exists, a hazard analysis shall be performed to identify the appropriate safe work practices that should be utilized during the excavation. Another area that's been updated, and this is another one that's been updated recently. It's going to deal with the charts that were available in 2009. The charts in the 2009 basically dealt with AC voltages. So it says general. All requirements of this article shall apply whether an incident energy analysis completed or if table 130.7 C15A or C15B is used. That's for AC and DC, and then the clothing that goes along with it. So what do those tables look like today? Let's see if we can find them here. If you haven't done a hazard risk analysis, and I don't know how this shows up on your screen, if your qualified employee knows how to read, knows their job task, knows their voltage, they can go into the set of tables, find the equipment, find the voltage, find the task, and without doing an analysis, come in here under hazard risk category and find the type of clothing that needs to be on their body. It'll indicate the minimum requirements. They need voltage-rated gloves, and the minimum requirements that they need to use insulated hand tools. Another one that's out there today, that's for AC. This is a continuation. This is the one for, I believe, DC, brand new, haven't had it before. Many of you have DC systems, if not as extensive. But again, what are they working on? voltage, equipment, and so forth, and give them some clothing categories for worker protection. And the final one that's in here is the category tables have been changed out there. And the biggest change here is going to be in Category 2. And again, I can't tell how this shows up on your screens, but in Category 2 today, they've eliminated 2 with an asterisk. We now have a requirement that over the head is a balaclava, a NASCAR sock, okay? So that's new out there. We no longer can be in a Category 2 with just a hard hat and face shield on. We've got to basically cover the entire head and so forth. So let's go back to the slide presentation. Give it a second to come back to where we're at. So when we talk about electrical safety work practices, again, out of Section 130.2, some new language. Energized electrical conductors and circuit parts to which an employee might be exposed shall be put into electrically safe condition if any of the following conditions exist. The employee is within the limited approach boundary. The limited approach boundary basically says if I'm within a certain dimension of an exposed part and piece, or the employer interacts with the equipment where the conductors or circuit parts are not exposed, but an increased risk from an exposure to an Arcflash hazard exists. That, folks, is a huge, significant change in this standard. Clearly identifies, interacts. What is interacting? That could be switching, turning something on and off, resetting devices with the doors closed. And that, again, many places, operators, people other than electrical workers have been allowed to do this. We have to find a way to protect and train those employees. It goes on to say then, if we're going to have to work on something hot, we also need to use something called an energized work permit. It says, when required, when working within the limited approach boundary or the Arcflash boundary of exposed energized electrical conductors or circuit parts that are not placed in electrically safe work condition, that is for reasons of increased or additional hazards, work to be performed shall be considered energized electrical work and shall be performed by written permit only. Again, another significant change because I might have a 480-volt system. The limited approach boundary was 3 foot 6 inches. I only needed that permit in that period. What if that now Arcflash boundary is 9 feet or 15 feet? This is adding more requirements. So what are examples of additional hazards or increased risk? Well, according to the NFPA 70E, here's a note that comes out of it. It says examples of additional hazards or increased risk include, but are not limited to, interruption of life support equipment, deactivation of emergency alarm systems, and shutdown of hazard location ventilation equipment. And there's a caveat that goes along with it. It's used in the industry, and it says where human life's on the line. So interruption of life support, hospitals, nursing homes, assisted living facilities, deactivation of the emergency alarm systems. What if you got monitoring up there for ammonia refrigeration system? You're protecting your employees and you're protecting the public. What if you got welding fumes and so forth like that? Under those circumstances, if I shut it off and put human life on the line, I would be allowed to do some of this work in an energized state using a work permit. Examples of work that might be performed within the limited approach boundary of exposed energized electrical conductors or circuit parts because of infeasibility due to equipment design or operational limitations include performing diagnostic and testing. Well, it has to be on to do a voltage test. It has to be on to do an ampering power factor study. But that's, if you got a problem out there, flickering lights, in the past, it would not be unusual. I'd go to a circuit breaker panel, you did your voltage test, you did this, and then somebody would pop a screwdriver out and see if the screws were tight on that circuit. That is not considered appropriate work. It needs, if that's what it is, that's repair and maintenance. It needs to be locked out, tagged out. But here's the other part. Or down here, an electric circuit can only be performed with the circuit energized and work on circuits that form an integral part of a continuous industrial process that would otherwise need to be completely shut down in order to permit work on one circuit or piece of equipment. But if you look at the OSHA regulation, they further clarify that, such as a chemical processing facility. So just because you're out there and you bottle wine that's a continuous industrial process, I'll guarantee you they would not buy that. So what are the elements that go along with this energized work permit? The energized electrical work permit shall include but not be limited to the following items. And it gave us the traditional three that were up there. But it also talks to us about we need to know what the results of our shock hazard analysis gives us out of the tables. It has to be the results of our Arcflash analysis. So these are the kinds of things that have been added to that standard. Approach boundaries. So what is this thing called shock boundary? The shock protection boundary identified as limited, restricted, and prohibited approach boundaries shall be applicable where approaching personnel are exposed to energized electrical conductors or circuit parts. Table 130.4CA shall be used for the distances associated with various AC systems, and Table 134CB shall be used for distance associated with various DC systems. In the past, it says if we hadn't done an Arcflash boundary analysis for systems of 600 volts or less, the limited approach boundary, or I take it back, the Arcflash boundary was 4 feet. We now have different tables for different applications, and that needs to be implemented because it could be something like 18 inches. It might be something significantly more. What about approach by unqualified persons? Unless permitted by 134D2, no unqualified person shall be permitted to approach nearer than the limited approach boundary of energized conductors and circuit parts. 130.4D2 deals with exposed overhead movable conductors. So again, more requirements to keep unqualified people out of that work zone. Arcflash analysis, an informational note. And this is, again, where we got to look at the reality of where we work. Both larger and smaller available short-circuit currents can result in higher available Arcflash energies. If the available short-circuit current increases without a decrease in the opening time of the overcurrent protect device, the Arcflash energy will increase. I recently had an individual call me up and says, Larry, when I was running my Arcflash analysis at this particular area, I only ended up with 8 or 9 cals. But when I changed it to this, and it was a lower amount of short-circuit current, I ended up with a higher number. Why? Because they said your overcurrent protected device may not clear. If the available short-circuit current decreases, resulting in a longer opening time for the overcurrent protected devices, Arcflash energies could also increase. So helping us further clarify how we go about doing calculations and the results. Protective clothing. Protective clothing and other PPE for application with an Arcflash hazard analysis, where it has been determined that the work will be performed within the Arcflash protection boundary identified by Section 130.58. One of the following methods shall be used for the selection of protective clothing and other personal protective equipment for each work task. And the requirements of 138 shall apply regardless of the method used to select the equipment. Equipment labeling. Electrical equipment such as switchboards, panel boards, industrial control panels, meter socket enclosures, and motor control centers that are in other than dwelling units, basically housing, and are likely to require examination, adjustment, servicing, or maintenance while energized shall be field marked with a label containing all of the following information. And this is some new language. At least one of the following that has to be done. The available incident energy and the corresponding working distances, the minimum arc rating of clothing, the required level of PPE, and the highest hazard risk category 8C for that equipment, regardless of the task being done. I often get asked, I got a label out there. It says 40 cals. Do I have to do that when I'm simply doing switching? And the answer is yes. You protect yourself from the highest potential hazard. The nominal system voltage of that equipment is at 120, 208, 277, 480, 4160, so forth. And item number 3, the Arcflash boundary. Now, the method of calculating the data support the information for the label shall be documented. In other words, are we using the IEEE 1584 calculator? Are we using some other software, SKM, and so forth? Got to be recorded and documented someplace. Housekeeping duties. Employees shall not perform housekeeping duties inside the limited approach boundary where there's a possibility of contact with energized electrical conductors and circuit parts unless adequate safeguards such as insulating equipment or barriers are provided to protect contact. This is helping clarify that when we got somebody going into the electrical room and working around electrical equipment, can they clean it? Do they got to be trained? It's been further clarified that limited approach boundary. Remember, the limited approach boundary is when you got an exposed part and piece. Electrically conductive cleaning materials, including conductive solids such as steel wool, metallized cloth, and silicon carbide, as well as conductive liquid solutions, shall not be used inside the limited approach boundary unless procedures to prevent electrical contact are followed. Again, folks, we got to train our people. What can you use? What can't you use? Arcflash protection then. What about head protection? And again, remember I was telling you before in those earlier tables, the old category 2 with the asterisk is gone? Well, here's the requirement for head protection. An arc-rated balaclava shall be used with an arc-rated face shield when the back of the head is within the Arcflash boundary. An arc-rated hood shall be permitted to be used instead of the arc-rated face shield in the balaclava. Again, a significant change in PP that's going to go on an employee's head. So it goes on to say this is reflected in Table 16, where the old 2 is now HRC 2. 2, an arc-rated hood shall be used when the anticipated incident energy exposure exceeds 12 cals per centimeter squared, the full hood. What about hand protection? Heavy-duty leather gloves or arc-rated gloves should be worn and required for Arcflash protection. Now, if you're wearing voltage-rated gloves and the leather that comes with them, that will meet the standard, but I can't simply go out there and get a real lightweight pair of leather for my other type of work. Informational note. Heavy-duty leather gloves are made entirely of leather with a minimum thickness of 0.03 inches or 0.7 millimeters, are unlined or lined with non-flammable, non-melting fabrics. Heavy-duty leather gloves meeting this requirement have been shown to have an ATP value in excess of 10 cals per square centimeter. I've been at some places where people have been given the leather gloves on the one side, and if you look at the other side, it's got this gray kind of polyester nylon in the back of it. In an arc, that's going to melt and burn. So I've covered a lot of things in here, and as I said when I started this presentation off, it is a very brief cursory review. So I do have a few seconds left here to take a question or two if somebody's got something out here. I'm looking to see if there's anything that came in here. I don't see anything showing up. So at this time, I'm going to just wrap this thing up and say if you have any questions about the NFPA 70 or this webinar or need more information, I've got a screen up here. So at this time, I'm going to turn it over to another individual from NTT to do our closing comments.
Thank you for attending NTT's informational webinar, the NFPA 70E, How the 2012 Updates Affect You. We hope that the information will help you maintain a safe work environment and keep yourself and your employees protected. If you missed a portion of the webinar or would like to share it, we will be posting it to our website. Larry covered a lot of information today and didn't get to all of your questions. We will respond to them as soon as possible. If you would like more information about our electrical safety training or other classes, please contact Debbie Jones or your sales account manager. Debbie's contact information is on the screen. Debbie Jones at nttinc.com or 1-800-922-2820. That's DEBIJOENS at nttinc.com. Please mention that you attended this webinar to receive special pricing for any courses booked in January, February, or March of this year. This includes electrical safety courses and others in these broad categories: the NEC, electrical and electronic, HVAC, fluid power, compliance, and mechanical and industrial systems. Thank you again for joining us today.